the pleasure of touring their facility the last time I was in town. And what they got going on is super cool. And I'll let Dan here talk more about it. But we are excited to welcome Dr. Dan Popa from the University of Louisville.
Hi. Thank you. Thank you, Matt. So Matt came to visit me about 3 months ago, and we chatted for quite a bit. And he told me, well, come give a talk at the Book Manufacturers Institute meeting. I said, I don't know anything about book manufacturing, but then it turns out I thought about it. Your industry in manufacturing goes back to the 15th century. It's probably precedes the Industrial Revolution, right? And here we are again, now on the cusp of another Industrial Revolution. This one, people call it with different names. You've heard of AI and robotics automation. So my talk today is about this concept called Industry 5.0. It's not my concept, but it's actually terminology that originated in Germany. Again, so Germany with the printing press, now Germany with Industry 4.0. So there's got to be something there. So my presentation has 3 parts. Usually I give a talk and there's questions at the end. This part actually will have some questions that I received. You guys submitted, so I'm going to try to answer some of these questions in the first part. So we're just talk about terminology, lots of buzzwords that you may hear. I try to clarify a few things. And then after that, I'll give some examples from my lab of things that we're doing right now. And it's research still. So as you know, research takes like 10, 20 years before it comes out. But I think the pace is accelerating. So you'll see a lot of these things come out in the 10 years. I would be surprised if they don't. And then the last, I'll try to talk about some new initiatives and future things that we may see. So first of all, there are 3 words here: robotics, automation, AI. There's many different definitions about what they are. So these are things that, you can take it from me. It's just one point of view. So robotics, typically we talk about this sense, think, and act trinity. That has to be embodied. So basically a robot has sensors, it has some processor, it has some thinking ability, and then it has some actuators. And if it has only 2 out of 3, it's not a robot. So my phone has sensors and can think, but cannot move, right? If you can sense and move, but cannot think, again, it's not a robot technically. It has to have all those 3 things. Now, automation has machines. Some of them are robots, some are not. You can think of machines as robots as well. But really, automation deals with reliability, repeatability, scalability, efficiency. And really not how you deal with uncertainties, how you reason, etc. And then artificial intelligence, that's the last one. Here, we're trying to create an artificial brain, something that thinks like us, right? So from a general point of view, an AI system needs to reason, discover, generalize, and learn. And usually, people nowadays focus on learning. That's an important ability, but there's many others that AI has to have. So you see this term machine learning sometimes used in terms of AI. All right, so these technologies, people say, and I believe that they are disruptive. Just like the printing press, they are disruptive. We're getting right now at the 5th Industrial Revolution, basically, with these. Now, in terms of application for industry, robotics and AI have a lot of potential. It can lead to better workplaces with, safer options, better efficiency. And the idea is it can help you increase your R&D potential. And then here, I put a quote from the Robotics Industries Association that defines what a robot actually is for that industry. It's a programmable, multifunctional manipulator that moves material and does a lot of other things. This is sort of a dated definition. Future robots are also going to work collaborative with humans and workers. So despite that the fact that these technologies are coming, the fact is that just 10% of companies have a strategy on how to implement these technologies in their factories. And the workforce, there's a great need for workforce that's trained with these technologies. You can see here there's hundreds of thousands in the US alone, hundreds of thousands of jobs that are open and unfilled. And, there's a growing need for introducing more and more of these technologies, but there's concerns about cost, for example. I'll speak a little bit about these aspects today. So in manufacturing, we talk about factory automation. It's defined here as the discipline that implements controls in specialized hardware. And automation typically has different levels. So at the level 0 or so rigid, everything is pre-programmed. The sequence of operations is pre-programmed. You can't really change that. At level 1, you can change the order, for example, or the duration of certain operation. That's called programmable automation. At the level 2, in addition to that, you can also move your assets around. It's called flexible automation. And that typically is done with robots. And the next level, that would be intelligent automation. So that applies these technologies I mentioned, AI and so on. This has been coined nowadays as a new term. It's called Industry 4.0. So when I talked to Matt a few months ago, I was thinking, what can I say about the book manufacturing? What do I know about it? And I remember that about 20 some years ago, I was involved with a project for paper handling for Pitney Bowes. So we actually had to make a machine that would stuff envelopes with paper, right? And that was actually a very challenging project. So we actually built the machine and we characterized the yield of, how many of the papers actually end up in the correct orientation and in the correct envelope. And the challenge was you had to open the throat of the envelope and put the paper in, and the paper shouldn't be jammed or crumpled, okay? And that's pretty difficult, right? So we used machine vision back, that was 20-some years ago. We used machine vision to look at the orientation of the paper relative to the envelope and how far the throat of the envelope was open, and try to predict how it's going to fold. And this is pretty challenging because paper is flexible, so it's hard to manipulate. And I think the same challenge applies today with current robotic technology. We are very good with our hands to manipulate paper, very easy for us. It's flexible and so on, it's light. But for a robot, that's very difficult. And so right now in robotics, a big challenge is tactile manipulation. I'll show you some examples where sense of touch is needed if you don't want to crumple things. So in your industry, handling one paper, copy individually is probably very challenging still for technology to accomplish. But taking batches of paper, probably a lot easier. All right, so a few more buzzwords here. So now if you combine robotics and AI, that makes for an intelligent robot. And then if you combine automation with robotics and AI, that's Industry 4.0. And Industry 4.0 was coined by people in Germany about 10 years ago. It initially, nobody knew what it was, and now it's getting traction. Even people here in the US are referring to Industry 4.0. Now, today, my talk actually is focused on the next level, which means you take Industry 4.0, but you add people in it. And that becomes Industry 5.0, again, a term that was coined in Germany. But the idea is Industry 4.0 does not need people. Essentially, you press on the manufacturing line, and then you get out of there, and it works by itself. It collects the data. It does everything by itself. Right. So in that way, automation is a job killer, right? So it's, there's a lot of concern, right? And there are statistics saying that for every robot introduced and every automation system, you lose 3 to 6 jobs. And this was certainly the case in the past. Okay. Now, after COVID, the equation is very different. Companies are no longer, and I'm sure in your industry is the same, no longer interested in layoffs. They're interested in how do we keep the workers that we have, and no, we don't have enough workers to even run the assets that we have. So you're interested in keeping people, right? So I think that now the paradigm is, okay, how do we find people for our production, our manufacturing lines, and how do we actually utilize these people in conjunction with the technology that we have for two reasons. One is to keep them excited and interested to work here, because otherwise they go somewhere else if they're not excited. And two, to increase productivity and make things more efficient. So this idea of robots working collaborative with humans, that's called a collaborative robot. They are emerging. They have been emerging for about 10 years, and there's a growing trend in industry to employ them. And then if the robot, I'm sorry, I said robot working with automation. It's a human working with automation. That's called human-centered automation. So if you hear these buzzwords, it means people are involved with the automation system. So if you look at this slide here, you see components of Industry 4.0. So there are many things here. I'll just point out a few. You have data analytics. That means you collect data off your machine, and then you can look at it and can tell you where things go wrong or where things can be improved. And this is not done necessarily by somebody. It could be done by the AI, right? There is robotics. There's cloud computing. There's 3D printing. There are many sensors that you have to install. And there's AI here, right? So there's a lot of different things in this, which for your, may not be suitable for every industry right this minute, but there are several leading manufacturers that are implementing these philosophies in their factories right now. Tesla, for example, one of the leading companies. So I saw that there were many questions from you. Maybe you can recognize some of the questions here. So I wanted to kind of go through some of these. There was a question here, where is AI most development taking place? China. So the answer to that is actually that's not necessarily true. There is development in China, but most of it happens still here in the United States and Europe. Right now, the U.S. government has invested into research, R&D. There's many governmental organizations, DoD, Department of Defense. They're investing heavily in artificial intelligence. There's a lot of research going on at universities as well. The second question was, so the ones that are not highlighted, I'm going to address in my future slides. How does one go finding contacts who may have automation solutions? So these, have to be industry specific, but there are large automation trade shows. ATX, for example, is one of ATX West. So all these systems integrators will get together at these big shows, and they have a huge display floor. So if you go to that, they can save you a lot of time. Now, all these folks may have no experience with your industry here. So you're going to have to kind of talk to them about, how they can use their products in your industry. So they are focused right now on manufacturing of cars, manufacturing of appliances, other things. But their technology is definitely applicable to what you're doing. Next question is, in 1984, so a factory in Japan that had automated all functions other than stripping wrappers of paper rolls. Why hasn't been much done to automate U.S. printing facilities? I had the pleasure actually to join the lunch table. There was a gentleman from Heidelberg, two of them. I think you're in the audience here. Maybe, maybe not. Oh yeah, you guys. All right. So I very quickly learned that much of the manufacturing base is not here. It's in Germany, Japan, mostly, right? That's where these machines are made. So that's where the development occurs, right? So for there's nothing going on here for that reason. But certainly, there are things that we can do, or U.S.-based companies can do. The next question here: what are the primary areas of production that have the greatest impact and benefits via automation? Okay, so as I mentioned in the past, for Industry 4.0 and for Industry 4.0, the idea is you put robots and automation in, you reduce the workforce. That is the motivator, is to reduce the workforce. You also increase quality, right? But primarily you reduce the workforce. For the next revolution, which is 5.0, the idea is you include the workers in the process of production. You make manufacturing more exciting. I'll give you some ideas there. So if you go to the car factory, right now there are robots handling welding tasks. Most welding is done with robots. Assembly of large panels into the car, the seats, the windshields, they're all done by robots. But then the smaller things, the flexible cable harnesses, the engine, the upholstery, all that is done later on the assembly line by people. And the reason for that is it's harder for robots to do those tasks. So in your industry, similar things, right? With the printing roll or roll to roll, printing, I think that's a term coined in your industry, right? For newspapers, right? There was little manual intervention until the end when you had to take the sheet and cut it, right? And fold it and deliver it. So that's probably where you want to introduce robots in the future if you're gonna do that. And that's related to last question about how are cobots really going to happen? Cobots, short term for collaborative robots. And the answer is, I think so. 5 years ago, I said, you're going to go, 5 years from now, you'll go to the store, buy your robot, bring it home, teach it how to cook for you. It hasn't happened yet, but it will. It will, not too far away. The bigger, so the one issue is the price, the expense. All right, so next part, and so I'm sure there may be many other questions. I'll wait till the end, or we can wait till the end for that. I'm going to move on. I'll go through some examples of work that we're doing at my lab right now. And again, this is in a university R&D facility. And some of these things may be closer to commercialization. Some of them may be farther. It's a combination of things. So let me introduce my lab. It's called the Louisville Automation and Robotics Research Institute. Actually, it's a large organization at University of Louisville. We have our own facility that's right off here, Highway 65. And there's a group of 15 faculty from the School of Engineering, Mechanical, Electrical, Computer, Industrial Engineering, all involved in this effort. We have R&D staff and students, graduate and undergraduate students, about 50 of them. Currently, we are engaged in research funded by the National Science Foundation, among other government organizations. We have about 10 nationally active projects. One of these projects is called the RAMPS project, stands for Robotics and Additive Manufacturing Pathways for Success. It's a grant from the Department of Education. And you see here sort of a rendition of what our facility will look like with this program. We want to create a collaborative space where students at all levels, including K-12, undergraduate, but also non-university students, and the community can come and kind of play with these toys. So lots of expensive toys. For example, a robotic dog from Boston Dynamics. We have a drone flying facility where you can fly drones. And there is collaborative robots all over the facility, robots that go and fetch things for you, that sort of thing. And the idea behind this is it's a showcase. Here's the latest and greatest in robotics. These are some of the tough things that robots can do, and these are things that they cannot do. And this is really not that threatening, okay? You don't have to be afraid of this kind of thing. The truth is that whenever we put on a tour, we have 20 robots in the facility. I need 20 to 30, 40 people to actually man those robots. So there's 2-to-1 ratio of humans per robot. It's not a case where the robots are taking over the facility. And robots are broken. You know, they break down much faster than they can function. So that's another challenge. Another thing we're doing is we have this program. We've had it for last 4 years. It's called our Campers Project, stands for Kentucky Advanced Manufacturing Partnership for Enhanced Robots and Structures, so handful. It is actually a very large project with the following vision here. On the left side, you have future manufacturing worker. On the right side is a factory with different robotics or types of manufacturing processes. And you want to connect the worker with those processes to this high-tech gear. Maybe you have a sensorized glove and a tablet and a vest that has sensors to tell you where the worker is or how far it is from the robots. A glove to tell you how much force or pressure is applying on different parts of the system. And there's a lot of data going back and forth between the worker and the robot, and that's called a collaborative human-machine interface. And people use human-machine interfaces. A touch screen is one example. Your mouse is an example, right? Video game controller could be another example. A teaching pendant for a robot is another example. But all these things are non-collaborative. What does that mean? They don't work with you to kind of help you operate the technology better. They are fixed. Somebody designed this for you. Somebody designed the touch screen for Apple and gave it to me. And so I just have to use whatever they gave me. And somebody invented the mouse, gave it to you, that's it, right? So what we want to do is actually let people actually customize and design these interfaces so that they can become more productive. They can customize parts of it and use it in conjunction with these wearable sensors. So I mentioned the sense of touch. One of the things we're doing is we're working with these tactile robotic skins, so pressure-sensitive robot skins. So these are, just like our skin, these are sensors that are deployed on the body of the robot, on the fingertips of the robot, so that the robot knows, hey, I ran into somebody, or I hit something, or I'm damaging whatever it is that I'm handling. Very important technology. A lot of work has been done to date on this. It's a sort of a holy grail. There are commercial products. They're a little expensive right now. It's a barrier to entry. We have some patents on this, and we have a way to actually make these sensors in our facility. So one of the ways that we make these sensors is we actually put together this system called the Nexus. It's a robotic additive manufacturing system. So it's an example of application of Industry 4.0. It has 5 robots in the workspace. It has some 3D printing tools, very unique tools. It has a control system, a bunch of sensors. It allows users to go into the workspace as well. I had a team of about 20 grad students and undergraduates that put this thing together over a period of 3 years. And I'll go to the next slide here. One of the features it has So you see there one of the robots that's picking up tools. So the tools could be grippers, it could be other types of holders, it could be dispensers. We also have a printing line, and there was interesting discussion today about a future for your industry to print flexible electronics. So this robot skin actually is a flexible electronic system, where on a flexible substrate, we print these tactile sensors, and we do that with this small nozzle here that can make 30 micron lines. So it's like an inkjet printer, except it's done with aerosol. So it's an aerosol, a specialized tool, very expensive tool, but it makes very fine lines over large areas. So you see here a print. I don't know if you can see it on the right side of a pattern. Those lines are 50 micron in thickness, in width, I'm sorry. So the idea is this system, it can take your substrate and present the substrate to this nozzle, print your sensor, then it will make interconnects, laminate it, and these bigger robots will take over and sort of complete the packaging to make what you see on the bottom left, which is a 16 array of tactile sensors that can go on a robot. Other things that we can make is wearable devices. So these are those wearables I showed you that the worker can wear. They again have sensors embedded in them. We can also make a printed circuit board with this conventional printed circuit board. We can populate it and so on. So multiple functions, and it's flexible. All right, so next topic, I want to talk about human-robot collaboration eventually. I'll start with human-computer collaboration, HCC. So Industry 4.0 in general needs human-computer collaboration. There's an operator, you have your factory, you have all these sensors and robots running around, but somebody needs to sort of supervise it and maybe, you know, operate the touch screens, right? So that's HCC. And, you know, HCC, you know, in a factory, you have a team. So people collaborate in a team. So human collaboration, it comes first, all right? This is how things were done in the old days. But then later on, somebody invented the computer, right? And then gave us all these wonderful tools that we use today. So now we collaborate with the computer. And we're more productive. Everybody's more productive. I hope you all agree. So in human-computer collaboration, people speak of 4 levels of collaboration. Level 1 is the computer is used as like a tool, like a word processor is a tool that everybody uses. Level 2 would be an assistant. So that would be either Google Search or Cortana or Siri, right? That's an assistant. Even ChatGPT could be thought of as an assistant. You request some information, it gives it back to you, right? So the next level of collaboration would be a peer. A peer means somebody you collaborate with. It could be like just another human, right? So this is where ChatGPT is going, basically. It'll be not just your assistant or a tool. It could be more like on par with you. It can, you know, you can do some things, but it can probably do more things than you can, right? So we're not yet at level 3, but that's where things are going with HCC. And level 4, the computer is going to be your manager, right? We don't want to get to level 4. I know that. All right. So this is, so HCC has been around since computers were involved, right? Since the 70s and 80s. But now, what I want to emphasize is we can do similar things in the human-robot collaboration space towards Industry 5.0. So just like I showed you examples with human-computer collaboration, human-robot collaboration will have similar attributes, right? Right. So we can use all the tools from HCC, but there are some differences. So in particular, we have this embodied robot, right? So it's not just the computer, it's an embodied robot. It's going to be intelligent, right? So the collaboration could be viewed as cognitive or physical. In your industry, you probably want some help physically to lift things, for example, or you also need help cognitively to know information, for example. So nowadays in collaborative robotics, people working on cognitive components of collaboration, like things like teach by demonstration and emotional engagement with robots, which is, again, in research phases. And then in the physical aspects, again, you have these collaborative robots, but you need to worry about how you teach them physical skills, how you transfer physical skills, for example, by demonstration. Kind of like apprenticeship, the way you learn how to do things from another human, a robot will have to learn to do things from a human as well. And also what's different is we need to worry about ethics and safety. So the robot should not be hurting anybody that's working closely with them. And then ethics means, robot should not be taking your job or should not insult you or things like that, right? It's important. People need to feel comfortable with this technology. And I have seen at other manufacturing plants, labor unions being very, very upset about introduction of robots, sabotaging the robots, etc. So these are real things that we have to pay attention to. So for a human-robot collaboration, it's similar to human-computer collaboration. At level 1, we have tools. So here with the robot, we can use teach by demonstration as a way to show the robot how the work is done. Level 2 is an assistant that has some kind of limited learning ability, machine learning, so limited AI. And level 3 will be a peer or a partner. So here we're talking about adapting, robot adapting to human, human adapting to robot. And I give this analogy on a cognitive level. You want the robot to behave like an AI in a video game. And from a physical point of view, you want the robot to behave like your dance partner. So it will anticipate your moves and kind of move along with you. And then level 4 would be the robot is going to be your manager or your companion. I don't know about this kind of future. This is what people have feared, but this is more science fiction now. All right, so some examples of level 1, level 2, and level 3 work that we've done. So these pictures are collaborative robots in different contexts. So you have them in, I'm sorry, let me move back. You have them in living at home. You have them in a manufacturing facility. You have them together working with a human to service, for example, a CNC machine, computer numerically controlled machine. And this video here, which I will replay, shows somebody guiding the robot by pushing it through these flexible skin sensors that I mentioned before. You're actually guiding the robot to perform some motions by pushing him. So you can take the robot and physically show it how to do things. That's what collaborative robotics gives you, a more intuitive way to interact with the machine. At the cognitive level, we are working with these humanoid robots. This is an example of a Hanson robot in our lab that kind of look like people. And so here you can actually converse with the robot and even become emotionally attached to the robot. It doesn't have to, right? It doesn't have to. You go to the next slide. So these are different examples of guiding motions, prosthetic devices that are intuitive to operate. So kind of reflecting the motion from the left hand into the prosthetic hand. On On the top right, there is a robot that's being taught how to pour a glass of wine by somebody showing it by, taking their arms and pouring the wine. And then after that's done, the teaching is done, the robot can actually grab the glass and pour the wine by itself. There is collaborative movement. For example, that cart is being collaboratively moved by the robot and the human together. And this is a good example of collaboration to fetch and lift things. And bottom right, you see a robot that can actually reach in bins and pick up items from the bin. And on a cognitive level, we have robots that can follow a person, make eye contact, and make facial expressions in response to a human. And then on the bottom right, my former grad student is operating that robot with a brain-computer interface. There's a bunch of sensors on your head, and you can blink your left eye, the robot takes a left turn. Blink your right eye, the robot takes a right turn. Right. So these are different ways we can interact with these robots. We have a project developing this robotic healthcare worker. It's like a nurse assistant. Let me go to the next slide. And that has inbuilt machine learning. We call this thing a neuroadaptive controller. You see this robot here at the hospital. It took 3 years to design and build this robot. And this video kind of takes you through different stages of development. You can operate this robot through a gaming controller. It has these omni wheels that can allow it to move in all directions. And eventually, so it can be pretty nimble, but don't be fooled. This is a 500-pound unit. So if it's not safe, it can crash through a wall or it can crash into a person and kill you. So you can see how strong it is. And so to make it safe, we had to install many, many sensors around it to be able to tell you where the person is. And that's a fundamental challenge with collaborative robots. They need to know where the people are, and they need to know how not to hurt the people, right? And eventually, you can ride this robot. So my students had a lot of fun here. And ultimately, you're going to see the robot deployed at School of Nursing and being operated by nurses. Move on to the next. So that's a level 2 robot. It has some intelligence. So for example, things that we can do is recognize items, right? There's video stream and there's machine learning to recognize certain items and then move to grab only those items. So if you tell it grab the mayo, it will actually identify the mayo and grab the mayo. And the limitations right now are that there's only a finite number of objects that we've trained this with. So if you say, give me the green beans, it'll get it. But if you say, give me the black beans, it won't know that object if we haven't trained it to recognize it. So one thing that we're doing with this type of technology is it's called robotic bin picking. So the robot can look into a bin that has a lot of items. It could be cluttered or uncluttered, and then the robot will recognize the certain objects and pick them up and move them to another bin. It's pretty important. Amazon has been working on for years on this technology. They want to fulfill your order. Right now, they have robots that are bringing items to an operator, a human that does the last mile. So, but the volume of e-commerce going up exponentially. So there's no hope to actually throw more workers at this. Amazon actually needs robots to actually fulfill the orders. I'm going to skip this. We can do many different things. Let me give you an example of so now moving on to level. So I gave examples of level 1, level 2, So tools and assistants, and now the future is partners or peers. Actually, this example here is more easy to understand. We are working on an autism robot. The idea is to try to interact with kids with autism in a way that is tailored to individual kids. So, for example, some kids have deficits, sensory deficits, some may have motor deficits, some may have other types of deficits. The robot will kind of try to exercise with the kid at their level. So if the kid is slower to move in response to a stimulus, the robot will slow down. If the kid is less autistic, the robot will speed up, and so on, kind of tailor the treatment. So this, again, uses machine learning, and it's bi-directional. So if the kid slows down, the robot slows down. If the kid speeds up, the robot speeds up. We're talking about imitation. So imitation in facial expressions and imitation in body gestures. All right. So these are some examples of things we're doing. Some may apply to your industry, some may not, but a lot of these things are being commercialized these days. So now I just want to talk about future directions. So we see this idea of a collaborative interface as key to Industry 5.0. So this collaborative interface will allow anybody, they don't have to be a robotic specialists, but they can certainly operate a robot, right? And this collaborative interface actually will go beyond what your video game controller does, in the sense that if somebody is skilled at operating the robot, fine. But if somebody is not skilled, then this interface will actually help them interact better. Kind of like a video game controller that helps you be good from the moment you pick it up, regardless of who you are. Okay, so we're talking about a device which has some embedded intelligence, can figure out what your skills are and what you need to do and help you along the way. So we call that a collaborative interface, and we're putting together a big research center right now to kind of push this idea forward. I mentioned that there is a lot of impetus and excitement in the U.S. right now, and a lot of funding by the federal government. So we're submitting this bid in a week. I was telling Matt that I'm consumed with this right now. We're putting on this bid for a 10-year vision for what's going to happen with humans and robots working together. Well, if we have these interfaces, then we're going to all benefit. So imagine the factory of the future where you have some robots and some people, and they work together in teams. I also imagine that some parts of the factory may be virtual. And so, for example, a factory will have a physical presence, but it will also have a satellite sites because, for example, the workforce is not available in some part of the country. So imagine a rural community here in Appalachia working on a plant somewhere in another state, okay? Or if you think about the Zoom version of a robotic work table, you can have that in your house and be able to work in the factory from your house, okay? So that's sort of the future that we see. The factory will not be geographically in the same place. It will be distributed across the internet. And again, they all use these advanced interfaces. So these interfaces could be in-body, on-body, could be on tools, in buildings, building infrastructure, and furnishing. So I can have a smart table that I work at, and I actually do manual work, or I have a smart tool that I use that I pick up with my hand. On body, that could be sensors that are on your body, like tattoos that actually have RFID on it. And then the last one is in body. That's more controversial. Or we think non-surgical in body. That's what that means, non-surgical. So, you can collect your thoughts from outside, but not through implants. Okay, that's too much. Okay. So this new initiative will have a workforce development pillar. There's going to be research, and there's also connection and networking with industry. We have 5 universities, about 27 faculty from different departments. The partners are University of Louisville, University of Texas Arlington and Dallas-Fort Worth, Cornell University, and it's upstate New York, Oklahoma State University, and University of Kentucky. One of the things we're trying to do with this idea is, now if we have these collaborative interfaces, we can expand the workforce. That means people that haven't thought about working in a factory can work in the factory. Maybe there are people with disabilities or young people that are good at video games but don't have any manufacturing exposure. And so our project actually will start by understanding the underemployed. Okay, so it's very important that this technology is used by people, right? So we need to understand if it'll be accepted, if there's a lot of feedback actually that we'll get from actual workers. And then we want to push this idea of factory as a robot and integrate the humans with the technology and the factory as a distributed system. So the underemployed, we can think of them as people with disabilities, people with injuries, young people, old people. They used to work in the factory, but they can't anymore because they don't have the physical strength. Well, the robot can help them, right? They have a lot of experience. So we actually put together this industrial consortium, and we have several membership tiers in this consortium. On the left is the nonprofit. So a lot of nonprofits have signed up. For example, organization representing people with disabilities, the blind, for example, or people with autism have joined. Other professional organizations, for example, metals manufacturers, Robotics Arm Institute is a member, and so on. And we also have companies on the right side that have joined at the platinum level. There are different benefits, tiered benefits here. So I'm just going to go to conclusions, and then I'll take questions. So Industry 4.0, I talked about that, combination of automation and AI, but it replaces people. So if you see Industry 4.0, not good for people. So Industry 5.0, that's the way to go, because we will actually get people engaged and employed, and not just people that can work right now, but people with disabilities. But we require this human-robot collaboration to occur. And important distinction is with computers, humans and computers, is embodied physical presence. And then human likeness, that's optional. So your robot in the factory doesn't have to look like a person, doesn't have to look like a sci-fi movie or what I was showing you, right? But there will be some kind of level of personalization and connection there. I showed you examples of 3 levels of collaboration. The tool level, that's a collaborative robot. At the assistant level, your Roomba at home is an assistant. And at the peer level, they don't exist yet. But they exist in labs around the country. And another thing, of course, to move to level 3, we need more research. Tactile sensing, human affective sensing, new types of controllers that have embedded AI and machine learning, and motor control units, etc. So last word of caution is all technologies have this emerging technology hype cycle. And this is a slide I found that talks about how people get excited about new technologies, but then there's this valley of, or throw of disillusionment, right? And eventually some of them will make it in. And I think we're here with this type of technology, but we'll see it. We'll see more and more of it in 5-10 years. So I wanted to leave this out here in case you want to take the survey. We have a survey with one question. What is the most important thing in human-robot collaboration? If you want to take the survey, we would really appreciate it. It has to do with industry engagement for our university consortium. For our consortium, this extra information is optional, but if you want to join our consortium, you're welcome. So, sorry? The deadline is today. We had started many, many months before. We already have 30 members, so we're good there. But this process is just getting started, so there's opportunities to join in the future. And I want to thank you for your attention. I'll take questions.
Awesome. And just so everybody knows, Dan was nice enough to already put this in a PDF and slides, and it's already on the Hoover app. So all of these slides are in the app already. So, questions? All right. Oh, wait.
Do you go by Doctor or by Dan?
Dan is fine. Yeah.
Dan, can you give us your thoughts on the impact or potential impact of ChatGPT and AI on the product of books? I know there's going to be a number of applications within the manufacturing, but specifically your thoughts on the product of books.
Well, so I have a Chinese PhD student. He's born in China. He's very bright, but has challenge writing. So he told me just a week or two ago, I'm going to take my thesis and put it to ChatGPT. And then that's going to correct and give me suggestions. And, I'm going to, finalize that. I said, well, that actually is a little bit like plagiarism because ChatGPT will give you this information. Not just that, but we're training this super monster entity that knows everything, including your thesis or whatever. So I can't really predict, but I can see already there's big disruption. Just another anecdotal thing. Somebody requested a program. So ChatGPT provided a program, said, write me a program that does this or that. You get code, actually, and that code actually works, right? So it has implication for people learning programming, right? So, yeah, great question. I don't know the answer.
Other questions? Todd?
What advice do you have for us in how we think or prepare for what's coming? Because I don't know how much of this is actually applicable to us today, but what's your thoughts on how do we get ready?
Yeah, I think embrace it. That's what I'd say. Find ways to use these technologies in your industry. I think that's the safest bet. Many times, the type of automation or robotics depends on the market or how many products, right? So it may not make economical sense to do a lot of things I showed you today. That's a different question, but you should be thinking about, is it feasible to do it? Even now, I think. And maybe the answer is no, but at least you actually get ready for it. And I think you want to make your work environment more exciting. Think about ways to make it more exciting for the young generation. So embrace, phones and all these advanced things. And, maybe you have more people or young people that can work in your industry. It's just the way it is, right?
So my question has to do with the jump from Industry 4.0 to Industry 5.0. Is 5.0 more productive, or is it a full employment?
Yeah, it's a full employment thing, not necessarily more productive.
Right. There's the old joke about the spaceship and crewed by a dog and a man, and the dog's job is to make sure the man doesn't touch anything.
Mm-hmm. Yes, I think that could be, but it has huge societal benefits to do it this way. And rather than resistance and excluding everybody and just having these automated production factories, I think that's, we're going to have a lot of social upheaval if we do it that way. Yeah.
So technology advances and it improves, and you've talked a lot about that. Cost also drops. 40 years ago, color scanning technology that cost about $1 million costs about $100 now.
Mm-hmm.
And do you have any concept of, based on what's already happened, of costs dropping? There are many cost prohibitive things here.
Yeah.
When will this be available, usable?
Yeah. So I can speak about robotics. So the cost of a robot is no longer driven by sensors, no longer driven by computing. It's driven by the cost of the motors in the robot. And right now, motors in a robot are thousands of dollars. And so if you have 6 of those motors, that's already $10,000, right? So that's the bottleneck. There's huge initiatives in China to produce motors for robots at scale. And, the same reason to bring down the costs. So when that happens, when the cost, so right now our industrial robot is 20,000 in that ballpark. It may still be prohibitively expensive for many, many things. But once that cost gets down to 10,000, as more and more robots are employed, right, then that's going to happen. Thanks.
Dan, thank you for being here today. Appreciate it. Very exciting. I have to question you about the 4.0 that you're talking about that's going to replace people. You don't want to do that. It's a bad thing. In my mind, if you're replacing people in a tedious, stressful function, and now you're taking those people and educating them to possibly run that robot or do more important things for your company, it could be a good thing.
So that's 5.0, Industry 5.0. So I think yeah, you're absolutely right there. But that's what Industry 5.0 is.
I'd like to ask everybody here, does anybody have any robots in their shops yet?
Yeah, a few.
One on packaging area.
Mm-hmm.
Cartons and puts it on palletizing.
Yeah, palletizing.
Okay.
It's a common.
All right. Anything else? No? Okay. So what Heidelberg's doing is we've gotten into the packaging business, but we're also doing logistics with the presses, bringing loads and bringing the loads to the folders and automatically loading the pallets into our folders. Okay.
Yeah.
And we have push-to-stop technology where it's short-run work. It picks up the codes, and at the very end of the folder, we can pick up the loads, the folded pieces, and palletize them on the skids. Now, our competition has the small robot that you said, a cobots, but it's not fast enough.
Mm-hmm.
You need something industrial. So that's what Heidelberg does, and we put more of a high-performance robot on the end of it. Okay, so now we talk about replacing folks. We're not replacing folks. We're actually making a job, just like you said, sir, easier for people to have to work. So right now we have a shop in Green Bay, Wisconsin, who has 2 folders side by side. And we have one operator running one folder. And the loads are getting loaded into the folders. And at the end, the robots are packing onto a skid and then bringing them to the perfect binders or the stitchers. But now you have one operator running 2 folders, and they're running 16 to 20,000 an hour, 16-page signatures, just to give you an idea of the speeds we're getting. Okay? So I just want everyone to understand that we are doing it already.
Yep.
Now, on the cutting side, the Polar's cutting side, we are actually cutting label work and robots on the end packing the labels into boxes already and then palletizing them.
Yeah.
So, the technology is out there.
Great.
And for folks who were at the 2019 spring conference, we had a company from Charlotte that showed some of the cool robotic stuff that they're doing. And you can actually go, for those of you who weren't there, go to the BMI YouTube channel and you can see his presentation about the other cool robotic stuff that they were doing. But so,
All right.
Dan, thank you so much. Thank you for being here. Really appreciate it.